Now, bonds represent something known as non-amortized debt. So to explain what non-amortized debt is, I think it makes a lot of sense to actually explain what amortized debt is first. So um, the best example of amortized debt is a mortgage. And let's say I borrowed $300,000 to purchase a house, and I was charged an annual rate of 4%, and my maturity on the loan was 30 years. What I want to do is develop what's called an amortization schedule. Basically, I just want to calculate what my payment will be, how many payments I'll make. That part's easy. So I'm going to actually make monthly payments because this is a mortgage. My mortgages are typically monthly. And then I'm going to do it for 30 years. Well, 30 years times 12 months is 360. And I'm going to go ahead and do all 360. It won't take that long. This is good stuff to know just for your own life if you buy a house. Then I need to figure out what my dollar payment will be. So this was just like my payment number, which one of the 360 payments is it? To figure out my dollar payment, I'm just going to use Excel to do the math, but this is, if I were to use the interest factor tables, the mortgage amount that I borrow relative to my payments that I make the borrowing occurs before the payments are made. So this 300,000 is a present value of an annuity. So I would use the present value interest factor of an annuity table at an N of 360 and then a rate of 4% divided by 12, whatever that will be. So I'm going to actually just do that math. So 4% divided by 12 would be the rate that I would use. This rate isn't on the interest factor tables that I created for you, so you couldn't use the interest factor tables to do this problem anyway. I'm not going to ask you to do an amortization schedule. I'm just trying to explain the concept of it. But Excel can figure out my dollar payment per month quite easily. There's actually a payment function, and then I enter my monthly rate, and then I enter my number of months. So it's 30 years times 12 months, and once it does this calculation, J3 times 12, it'll get 360. My present value is this 300,000. I want it to return a positive answer as my payment, so I have to enter a negative present value. My future value would be 0. And then type just is whether it's an ordinary annuity or an annuity due. And I'm just assuming it's an ordinary annuity, so I don't need to input a type number there. My payment will be constant every month, so I'm just going to link the second month's payment to the first month's payment, and then I'm just going to double click to copy that down. So that's how much I owe every month on my mortgage. Now, the total repaid to the bank will be the sum of all of column B, or I could just take the 1432 and multiply by 360 because I know I'm making that many payments. So I'm going to pay the bank a little over $500,000 on a $300,000 mortgage. So my interest is going to be the difference between this 515,000 minus the 300,000. So 216,000 approximately in interest. Every payment that I make, a portion of it represents interest, and a portion of it goes to repay the 300,000 that I borrowed. So what I want to do now, and that's actually what amortization is, breaking each payment down into what portion is interest and what portion is principal. So I want to do that now. So for the first month, the amount that's interest is just my starting balance on the loan, the 300,000 times the monthly rate. So I paid the bank $1,432. 1,000 of that is interest. The rest is principal. So the rest would be 1,432 minus this 1,000. So 432 is principal. That means I'm giving this much money to the bank to reduce the amount that I owe on the loan. Well, I started the month owing 300,000. I reduced that balance by 432,000. So now I only owe $299,568. The second month, the interest portion of this payment of $1,432 will be my monthly interest rate times what my ending balance is on the loan this month, or I should say beginning balance this month. Well, my beginning balance is a little bit lower than it was the month before because I paid some principal amount on it. So my interest declines just a tad. I still paid the bank the same amount I paid them the previous month, so my principal amount's going to go up just a tad. Take the payment that I made to the bank, subtract the portion that's interest, and I'll get my principal portion. My ending balance at the end of the second month will be the previous month's ending balance, subtract the amount by which I reduced the loan that month, which is the principal of $433.69. So my ending balance is a little bit lower now. And so you just continue this process. I think I always need it to refer to this rate in K2, so I just need to make that what's called an absolute reference. And then it should do the math just fine. So I'm going to double click. Every single month it's taking the previous month's ending balance, multiplying by the monthly rate to get the interest proportion or amount. It's calculating the principal amount by taking the interest, deducting it from the payment. Then it's calculating the ending balance by taking the previous month's ending balance and deducting the current month's principal. And you can see ever so slowly the amount that's interest drops, the amount that's principal rises. And I'm going to scroll down to the bottom, and when we get to the bottom, our balance should be exactly zero. That's how an amortized loan works. Debt isn't an amortized loan. It's what's called, or bonds are not amortized loans. They're non-amortized borrowing. What non-amortized borrowing is basically just every month you pay only the interest. So how would that work? I'm going to redo. Actually, I think what I'll do is just create a duplicate sheet, and then I'll save the spreadsheet so y'all can look at it. So I'm just going to copy this. This will be my amortized one, and this will be my non-amortized one, if y'all want to look at this. Alright, so for a non-amortized loan, every payment that you make is only interest. So I would take this monthly interest rate multiplied by the mortgage amount. So I would only make a payment of $1,000 a month, which is exactly equal to the the interest that I owe. I don't pay any principal back on a non-amortized loan. Just every month I pay only interest. So the principal never gets paid down. The ending balance never drops. So finally, when I get to the last month of my loan, I still owe the entire amount that I borrowed. So can you imagine if a mortgage worked this way? And people like these types of loans, at least they think they like them until they realize they still owe the entire principal at the end of the mortgage. You'll hear these referred to as interest-only mortgages. But so the reason they like them is because the monthly payments are lower. I was only paying $1,000 a month instead of $1,432 a month. Um, but at the end of 30 years of making payments of $1,000 a month, you still owe the bank $300,000. If mortgages worked this way, home buyers would discover that after 30 years they had to come up with $300,000 to pay all the principal at once, and they didn't have the $300,000, so they lose their house. And look how expensive this particular mortgage is. Look how much interest we would pay. Even though my monthly payments are lower, my principal never drops. So my interest is going to be the sum of all of column B. So it didn't start till B2. So from B2 to B361, there's the total interest that I paid, $360,000 compared to only $215,000 with the amortized loan. But this is the way corporate debt works. For that, I've forgotten what company it was, Goldman Sachs. For Goldman Sachs, I can't tell by looking at the uh, internet site. I can't tell how much money Goldman Sachs actually borrowed, but let's say they borrowed, I don't know, $100 million. And they are paying 5% a year on that. So essentially every year they're paying 5% times 100 million. So they're paying $5 million in interest every year. Now they're not doing it in a lump sum. They're paying it, remember, in $4.16 or 17-cent increments for each bond. But ultimately it translates to $5 million a year for the next decade till September 2025. They'll be paying $5 million a year, and then on September 15th, 2025, they have to pay the principal back to all those bondholders. They have to come up with $100 million to pay those bondholders. So sometimes corporations will, here I'm going to put see Excel file because these are just the transcripts for the notes. So you'll know at this point to look at the Excel file. But to increase the certainty that the corporation will be able to pay back that huge principal amount at maturity, sometimes corporations will have what's called sinking funds. And basically it's just an account that they will sink money into typically every 6 months, or actually I should say typically every time they make an interest payment, because that's all they're obligated to make to their bondholders at that point in time. But to increase the certainty, they'll have all that principal, let's say $100 million in Goldman Sachs's case. They will deposit money into that account or fund. The goal is to have that fund be worth however much principal they're going to owe all of their bondholders at maturity. So the goal is to have in the fund at maturity the amount owed on all the principal. So they can just take all of that and pay it as a lump sum to the bondholders at maturity. From a bondholder's perspective, the existence of a sinking fund helps reduce risk. So it's a good thing to have a sinking fund. I'm just sorry, I'm just taking a moment to look at my notes. And, ideally I'd edit out that blank space, but I'm not gonna. Okay, I want to do a little well, let me see. Hmm. You probably are aware that mortgage rates change all the time. They don't necessarily change drastically from day to day at all, but um, I remember when mortgage rates were 6% or actually even 9%. Right now they're a little less, I believe, than 4%. But they do fluctuate. And I want to talk about what happens with a mortgage and then relate it to a bond. Banks, I don't know if you're aware of this, but banks sell their mortgages sometimes. So let's pretend this particular bank was going to sell this mortgage. So let's say 5 years ago I took out this loan back when rates were 4%. And let's just, for the sake of argument, assume that rates have increased and not decreased, because I think it maybe it'll be a little easier for you to understand if rates are going up. So 5 years ago, I took out this mortgage, and I've been paying on it diligently for the past 5 years. That means I've made payments 1 through 60. So we're now at here. So this is how much I still owe on the mortgage. Again, I don't need you to be able to calculate this. I mean, for your own information, it would be good to know just for real life, but for the test, I'm not going to ask you to be able to calculate stuff like this. I'm just interested in your understanding the concept. So we still owe this much money on the mortgage, and the lender, let's say it's Whatcom Educational Credit Union, decides to sell the mortgage. But let's say a big issue is that interest rates have risen to, I don't know what, I'll just say 7%. If another bank, let's say, oh, I don't know, Bank One, that'll be my lovely name for a bank. If Bank One pays exactly $271,342.54 for the mortgage, then they're only going to earn 4% a year. And where did I get that 4%? From up here. That was the rate the mortgage had when it was first lent to me. Well, they don't want to earn only 4%. They could do a new mortgage themselves and earn 7%. So it doesn't make sense to pay this much money for a mortgage that's only going to generate 4% for them. They want to earn 7%. They cannot come to me and say, because WeQ has sold your mortgage, you now have to pay me, Bank One, an interest rate of 7%. It doesn't work like this. This is a fixed rate mortgage. I, as the borrower, will only ever have to pay 4% over the entire 30 years. If it were an adjustable rate mortgage, that would be different. But this is a fixed rate mortgage where the 4% was guaranteed for the entire 30 years. So as the borrower, I don't have to pay them anymore. Any more than 4%. I still have to pay them that. The only way for Bank One to be able to earn more than 4% is to pay less than $271,000 for it. And we could figure out how much Bank One should be willing to pay. I'm only going to do this again just for demonstration purposes. I don't need you to do this on the test. But to figure out how much Bank One should pay for this mortgage, I know they want to earn 7%. It's a monthly mortgage, so I'm going to divide by 12. It doesn't have 30 years remaining on it. It only has 25 years because I've done payments 1 through 60. So 25 times 12 is the number of payments. How much am I going to pay on the mortgage? $1,432.25 this monthly payment. So Bank One knows if they buy the mortgage from WeQ, they're gonna get $1,432 from me. as the payee on that mortgage, and they will get that from me for 25 years every month, and they want to earn 7%, not the 4% that I'm paying. And I have to make this negative, or I like to make it negative to make it a positive answer. There's no future value, and the type is still an ordinary annuity. When I press enter and Excel actually crunches the math, it should determine an answer that's less than $271,000. Again, because if Bank One pays exactly $271,342, they'll only earn 4%, but they want to earn more. The way to boost that rate of return up to 7%, given a fixed payment that they'll receive of $1,432 from me, is to pay less than $271. So they would only pay WeQ $202,000 for my mortgage, but I would still have to pay Bank One now in this case this much every month. Bonds work the same way. If I own a bond and I want to sell it, bonds are fixed rate debt. Goldman Sachs is always going to pay a 5% coupon rate on this bond through September 15th, 2025. But interest rates fluctuate all the time. If I sell this bond to somebody who wants to earn a rate higher than 3.81%, then they're going to be willing to pay less than $110.50. Because the only way to boost this rate of return is to pay less for the bond when you buy it, because it's a fixed rate security like a mortgage. So that's why prices of bonds fluctuate all the time, because investors' desired rates of return fluctuate all the time. I know I'm not typing a whole lot on my Word document, but hopefully I'm typing enough. So I'm just going to write that down. When interest rates rise in the market, I guess is not really necessary, bond prices tend to drop, but they don't drop equally across the board. Like bonds that have a longer term to maturity and a lower coupon rate will drop more. It will drop in price more, I'll say by a greater degree, than shorter term bonds or higher coupon bonds. So different mutual funds have different types of portfolios. Some mutual funds have a collection of long-term bonds. Some mutual funds have a collection of short-term bonds, or high coupon rates or low coupon rates, just a different mix of bonds. And when interest rates are changing, these bond portfolios are going to be fluctuating in price by varying degrees. Another thing about bonds is the call feature. So one thing that we saw on this bond is it just says callable, no. So I need to explain what the call feature is. Y'all probably have heard about refinancing a house. Let's say in, oh gosh, I don't know, 5 years ago, which was 2010. And so in 2010, I borrowed $300,000 to buy a house at a rate of, I'm just going to say 6%. They weren't that high back then, but I'm just going to use that number anyway. And today, rates have dropped to, let's say, 3.8%. So they've dropped a good amount. And I've been paying on my 6% mortgage, but I'd much rather pay only on an 8%, 3.8% mortgage. I'm just gonna, for the sake of demonstration, I'm gonna pop up here. Let me just check and make sure all my numbers will change when if this had been 6%, look how much interest I would have paid versus the 4%. And now I'm going to change it to 3.8% just so y'all can see how much lower it's going to be. So just watch this yellow number. So now if I change it to 3.8%, look how much money I've saved in interest. It's just phenomenal. So people like to do what's called refinance a mortgage if rates drop enough. Refinancing a mortgage isn't free. You have to pay loan origination fees and refinancing fees. That can be a couple of $1,000s. So unless rates have dropped by a fair amount, and the idea is if they've dropped by about 2% or more, it's probably worth your while to refinance the mortgage if you plan to stay in the house for like another 5 years at least. But people like to refinance because it reduces the total interest that they owe. Bond issuers like to refinance as well. So I don't really have a spreadsheet set up to show you, so I guess we'll just have to work with this conceptually. If the current level of interest rates have dropped enough, then it might be worth the corporation's while to issue a new bond and refinance the old bond. Now the way that refinancing works, so I had a 6% mortgage that was 5 years ago, so I'm right here again on my payment schedule. So I still owe, let's say, about $280,000 on my mortgage. What I would do is go to a bank, take out a loan for $280,000 at the new lower rate of 3.8%, and I mean, I wouldn't have to sell my house or anything. It doesn't work like that. I just take out a new loan for $280,000 on my house, and then immediately take that cash that I've got from the bank and use it to pay off my old mortgage. Now, who benefits from that? I do as the borrower. Who is frustrated by that? The bank who originally lent me the money at the 6%. They would much rather be collecting a 6% interest rate from me over the next couple of decades instead of getting all this much cash from me at once. They're going to get this much cash from me when I pay off my old loan, and then they're stuck having to re-lend it to somebody else at a time when rates are only 3.8% and not 6% anymore. So the original lender is going to be frustrated. But there's really not anything the original lender can do about that so long as the mortgage contract allows you to refinance your mortgage. And I've never seen one that didn't. That doesn't mean they don't exist. So when you buy a house, you need to make certain that you're allowed to refinance it should you wish to. Unless, I guess, rates are so incredibly low, you're pretty sure you're never going to want to refinance it. So how does all this relate to a bond being callable? The call feature basically refers to this. The call feature allows the corporation, the issuer, in this particular case Goldman Sachs, to call in all old bonds, basically for refinancing. They don't call it refinancing, they call it refunding, but it's technically refinancing in the same sense as a mortgage. From the corporation's standpoint, this call feature is a good thing. They are able to retire these old bonds. They would issue new bonds at a lower rate, use all the cash that they generated from issuing those new bonds to pay off all these old bonds. And the old bond holders are required to turn them in. They don't have to turn them in for nothing. They get paid typically principal plus a premium for having them being called in, but the old bondholders are in the same position as the original lender on that mortgage. The corporation would be calling in, retiring these old bonds that have a high coupon rate. The bondholders would get cash for that, and then they'd have to go and reinvest that cash in the market at a point in time after interest rates have declined, because that's typically when corporations want to refund or retire their old bonds, just like that's typically when borrowers want to refinance their mortgages. So from the bondholder's viewpoint, the call feature is not a good thing. From the bond issuer's viewpoint, the call feature is a good thing. The Goldman Sachs bond, though, was not callable.